What does SCM mean to you?
You know, it's how you version the code for your product, right? It's, I mean, it doesn't have to be code, obviously. It can be data, it could be assets, binary files, whatever. But you know, typically used by software developers, right? I mean, it's got to be ubiquitous in our industry, right? Is there anyone that isn't using version control? Do you come across people who aren't using it?
Oh, that question comes up. So it's funny, not professionally, fortunately. I mean, it's impossible. You can't use GitLab without using Git. I don't think so. I mean, you can use the issues and stuff like that. I mean, quite frankly, issues of version. We even version control the description of issues, and so no, practically impossible. But yeah, Renfe. I'm Spanish. Renfe is the national. So it's a huge company. It's the national railway system. It's public. They version controlled their website, at least, which is not that important, but yet through comments. So they did not version control anything. They would just mention in code comments that they had changed this and that. The reasons.
Wow.
So yes, you'll find people that don't even use CDS or SVN to mention, I don't know, older systems, but clunkier. But anyway, so I agree with you.
As you said as well, it's it's an important tool for collaboration. So for managing the integration of features coming into your product from developers in the team, and just generally managing the team and how they're contributing and looking at what they've done and being able to code review it. Code review, how would that be possible in these days of remote working without version control? So it's kind of like the source of truth for the product, and everyone can contribute to building that and put their changes into it. But along the way, you've got the full history, and it's like I take it for granted every day, like pretty much every other developer. But occasionally, I kind of reflect on it and think, wow, this is amazing that we have this tool that we can work with that basically allows time travel. Like we can go back to any point in the product's history, reconstitute it, find out if a bug was added in that revision or not. I mean, these things have been improving for a long time, right? But they must be almost at their peak of sophistication now. Yeah.
The thing is that, so initially this use case internally here in GitLab, we were calling it SCM, so source code management, right? Although SCM stands for software configuration management too, which I think actually refers to another topic, more infrastructure based. But anyway, let's not go into the discussion of acronyms and how much I hate them. But we changed it for two reasons. Basically, because there's a part of the product, again, this is marketing, although product marketing, but marketing yet still, that is called SCM. So it's the features related to making Git available, the layers we build on top of Git, right, at GitLab. Yep. And so not to confuse it with the product team, but also because of what you just mentioned. The fact that it's all more about version control and collaboration rather than source code itself. So just like we were mentioning that Lean Pub and Manning publication, or the MEEPs version of Manning, was the translation of agile product management to publishing in a way. I think that the learnings from source code management, be it version control and collaboration in code review and code comments and integration conflicts, which is something I'll insist now, can translate regardless of the digital asset you have in hand. So source code management is text-based and it integrates well, most of the time, and it is suitable for code reviews and so on. But I think that the software industry is transitioning from functional teams, so only developers, only ops, only designers, to cross-functional teams. And that's why I'm of interest. It is of interest for me for GitLab, because I think that a platform, a tool that supports all digital assets and provides version control and collaboration, regardless of the asset you work for, a design, an animation, a data pipeline, a data set, etc., should be what people is requiring now.
Well, as you know, I come from a background in the games industry, so whereas a lot of software development teams are only sort of becoming cross-functional now, game development teams going way back always were comprised of developers, artists, designers, and anyone else who was needed to put a product together. At the last company I worked for before I started my own startup at Real Serious Games, we were building serious games, so we didn't have artists and designers as such. We had artists and engineers. So actual engineers who would normally be working on construction projects and that kind of thing were there basically, working with us, working with the data sets, interacting with version control to help build product. So I got a bit I could say about cross-functional teams. I kind of wanted to say something else about what version control means to me, though, because I just thought of one more thing.
Yeah.
And that is that something I think that's really essential to the development process, and that's iteration. So the whole code a little bit, test it, code a little bit, test it, code a little bit, test it, and you stack up many small tested working changes. That the sum total of that is a huge feature for your product, something like that, right? And version control is kind of like what makes that possible in a way, because every time you test it and you get it working as a checkpoint and you commit it. So if at any point you get into trouble and you've got a problem that's sort of beyond your control to figure out, if you're doing these small iterations and small commits, you can easily revert your change and just reset to a tested, known version of your software. I think that's really important. Also, though, if you do, like I said, if you get yourself into this problem and you've got a bug you can't solve easily, you've been through all the usual means of trying to solve it. The other thing you can do with version control, I guess this is only possible with distributed version control, which is sort of the new type of version control. Well, I guess it's been around for a long time now, but
15 April 2020, so last month. Git turned out Git. There's more distributed version controls, but Git turned 15. Oh
wow! Well, I've been using version control for over 20 years, so I started with Visual Source Safe. But anyway, that's digressing. What I was going to say is that if you've got a problem that you can't solve, and you want to know what it is, you can basically look at the diff between your working copy and the latest working revision, and whatever bug you've added is going to be hiding in that code. So it really narrows down the space. And you can do really cool stuff as well, like, find a fresh copy of the repo to compare against your modified copy and stuff like that. Lots and lots of, tricks like that for working with version control, while you're developing the product.
Would you consider that, going back to iteration, that each increment and therefore each iteration should be covered in one branch? So how do you define iteration? Is it a task? Is it a feature? How long should that last? I mean, what is the correct amount of work that should go into a branch? How does iteration reflect on the branching model, if they are connected at all?
Well, I'll talk about the branching model separately, but iteration for me, there's no correct amount of work to do in an iteration. So I'm not really talking about your agile Scrum iterations of 2 weeks here. I'm talking about sort of personal coding iterations, which could be 5 minutes, it could be an hour, it could be a day. For me, the smaller the better. The smaller the better, because you're racking up useful tested work, and that if you do go down a dead end or a wrong path, you can easily back out of that and not lose much work. So for me, small iterations are key. Sometimes it's not possible. Sometimes, you have to nut out a problem for hours and hours and hours before you can commit. That's perfectly okay. There's no right answer to this thing, but generally I think the smaller the better. And usually I encourage my developers to push at least once a day.
How does that connect, if any, with branching? I mean,
yeah. So I don't think that necessarily relates to branching.
Okay.
I personally, I think branching is overused a lot. I've seen it overused. I'm not a big fan of branch per feature or branch per developer, and that's totally okay if other people want to do that. I'm not saying it's necessarily a bad thing. It's just personally, I think overpopulating a repository with branches just makes it more confusing. And like I don't necessarily see the benefit in it. And I also think that having separate branches, I think that it's detrimental to continuous integration. And I prefer to have developers all contributing to the same branch and have it all being integrated daily if possible, and having the automated tests run on it. And that, when everyone's working off the same code base, everyone's going to be, I think, more forgiving of each other, hopefully, and more understanding of, problems going in, and work together to fix problems as they go in. If you cause a problem that affects your teammates and you see that directly, you're going to be more careful with your work in the future. So I think it promotes that kind of consciousness in the developers. I do like having a branch for. Sorry, just go on.
No. Go ahead.
I do like having a branch for obviously a master branch for development, and, a branch for production. Maybe a branch per release if you've got like a kind of release model. Or sometimes I like to use tags as releases. And I just encourage people or developers to basically fork the repo as well. There's no reason to create a branch for something temporary when you could just fork the repo or, clone a separate copy of it and bring it back to the mainline, if and when it's ready to come back. But, temporary experimentations, temporary demos or whatever, they don't necessarily need a branch. Just in my opinion, it just clutters up the repository, and a fork would do the job just as well.
Last comment on the branching model. Even if we're talking about a trunk-based development branching model, in the sense that let's ignore production, let's ignore development. There's only one branch, master branch, and each iteration, going back to your definition of iteration, would be branched out. So we're talking about short-lived task or iteration-based branches. Would that make sense? Is that is immediately or hours later or minutes later merged back to master? That would be my definition of trunk-based branching. And
well, normally what I do as a developer is clone the master repo, the master branch, make changes to it, and then I push it back to the hosted repository.
Okay. Which
triggers continuous delivery. Okay. So I can test in the testing cluster. And this is for my latest product. Different products can be structured differently. But and then when those changes are tested and I'm ready to push them into production, then locally in my local clone, I'll merge them into the live branch, and then I push the live branch to the hosted repository. Okay. And that's what triggers the alternate continuous delivery build that pushes to production.
When does code review, in your experience, maybe in this product or in general, happen? At what point do you request approvals, reviews, etc.? Where do you suggest that should happen?
I think it depends on the team. Really, it's a decision you've got to make for yourself. Before I started using distributed version control and I was leading teams, I'd like to basically have code peer reviewed by the person sitting next to you before you commit. But since distributed version control, I think better just commit, push, and then use the hosted software basically to do the code review and make changes basically before the code gets merged into production.
Okay.
Or maybe into a staging branch if you wanted to have a staging branch in between development and production. Okay. That's where you do your code reviews.
Even if let's imagine that the world is going to stay this way. I mean, hopefully not in terms of health, but rather only in terms of work from home. So in a remote distributed way. And you don't have the chance to tap on your colleague's shoulder or meet with him personally to pair program or actually review your changes. What does the state of code review look in that landscape of full remoteness?
Yeah, I think in a way it can work better because it's totally offline. It's totally decoupled. No one gets bottlenecked by anyone. It's just sort of, you're just queuing up changes basically that you ultimately want to go to production. And so they just have to pass through this online code review system. And once they're approved for that, that's the checkpoint to go into production and start being tested for that.
But what about a ping pong discussion, or do you reckon that's going to be more complicated? Are we lacking? Is oral communication?
As I say, nothing beats a good face-to-face conversation.
Okay.
So you know, I think if you're not having those daily, or you know, at least weekly, you know, there's going to be a lot of miscommunication. But certainly, I think a lot of it can be done online in the tools. And you know, if it gets complicated and messy, then you bring it into your daily stand-up, or you know, your daily one-to-ones or something like that.
So basically, the difference there would be oral communication versus written communication, in the sense that you're telling me implicitly that if conflict keeps arising by a ping pong discussion, by a code review or a code approval, or anything that just doesn't let people over written comments agree upon something, you're telling me that oral communication in dailies, weeklies, whatever, is superior to communicate, I don't know, complex ideas, complex code bases, complex changes, rather than written communication that is incapable of explaining those things, or I'm getting it wrong?
Yeah, I think so, because when you're having you know, face-to-face communication, you get instant feedback, and you know if someone doesn't understand, or you know, or they're taking it the wrong way, or you know, whatever the misunderstanding is, it's going to be apparent a lot more quickly than it is through you know, written communication. So you can adjust your communication style as you're talking, as the conversation progresses. So you know, that'll help work things out, I would think, a lot more easily.
So now my interest is moves to actually version control and collaboration over ELT pipelines. My definition, although pretty academic, is extract, load, and transform pipelines. What is your opinion on the current state of version control, only version control, on the different phases of extract, load, and transform? Is it something that is completely achieved with Git right now? Is it not?
I think you know, current version control works pretty well for textual data, you know, CSV files, XML, JSON, that kind of stuff. You know, version control was built from the beginning to work well with text data, i.e. source code. So it works well for that kind of data. It's never worked particularly well for binary assets, binary data. There have been some exceptions over the years, and those exceptions are some of the ones that have become very popular in the games industry for working with data. But like, in truth, I kind of wish there was a good distributed way of handling binary data. You know, but I'm not sure if we're ever going to see that.
What would you say is the main problem handling distributed binary, handling this in a distributed way binary files? What's the problem?
Well,
what's the main problem?
There's a couple of problems with it. One is that the program itself doesn't understand the structure of the data like it does with text data, and because of that, binary assets are not mergeable, which means that whenever people are working on on binary assets in version control, you know, if two people make the change at basically the same time, you know, one of them is going to lose their work. So earlier version control systems before distributed version control would handle this through locking. So if I locked an asset, you wouldn't be able to check it out and make changes to it until I had finished working with it. And so that prevented, you know, this overlapping changes and merge issues, and it handled it quite nicely. I think distributed version control by its very nature, it just can't ever do this kind of locking mechanism. Because, you know, it's distributed. We don't know where is editing what, because it could be offline. They're not talking to a server to let it know that it's being locked. So, you know, I've worked on teams where artists and designers have lost their changes and become very upset about it. And you know, on those teams, it was always really essential to turn on locking so that, you know, they weren't interfering with each other.
Because locking seems like like a shortcut in a way, in the sense that we are not focusing on the real problem that would be understanding binaries. Is that because? Do you reckon
that's true? But then there's there's potentially an infinite number of binary formats, so it could be a losing battle to even attempt to go down that route.
But how do you reckon plastic and perforce and how do they cope with binaries? Is it only because they provide lock-in features, or are they capable to understand the data structure of binaries at least better?
There's a lot of well-known formats that have like published formats, and you could potentially merge them.
Like which ones, for example? Off the top of your head?
Like 3D file formats, image file formats, am I thinking of point cloud formats, stuff like that. Okay. Plenty of well-documented formats, but again, there's just so many of them, and I don't think there's that huge of a market to provide that kind of feature. And a lot of games companies have basically rolled their own solutions for managing asset pipelines in this way as well. That are sort of workarounds bodged on top of version control systems. The other thing is that distributed version control systems, and I know there's a plugin to Git, but usually they don't handle large files very well either. So that's another, because some of these binary assets are huge, potentially gigabytes, maybe for videos, something like that, they're going to be gigabytes. So, but you still need to kind of store them somewhere and have a convenient solution for storing them.
Do you see any advantage anyway of people working with data sets, data pipelines, the ability to version them and so on, to have, because I'm thinking of data pipelines as the integral part of products that are heavily reliant on data. I'm not sure any application of related to COVID right now must have. It has like an interface it's probably an application. It's probably a web interface, whatever. But behind that, there's huge data pipelines consuming, extracting, loading, and transforming data from I don't know how many sources. I mean, it just baffles me. So, is there any benefit in the fact that the data scientist in charge of those ETL pipelines has his or her code in the same repo as the source code that enables the website, the app, the actual software itself? Or can they just cohabit elsewhere? I mean, can they work separately? I mean, that would be my
that kind of structure is really dependent on the project, isn't it? But if you're building an ETL pipeline, the code that's in it, the configuration of it, it's like any other code. Of course, you're going to want to version control it for all the same reasons that you'd want to version control any code. Like if you're working with a huge amount of data and you're seeing a huge amount of data coming through your pipeline, you're probably not going to be trying to put that data in version control anyway. You're probably going to be putting it in a database or, like a data lake or something like that.
Or warehouse, right? Yeah. Why specifically that? It's not because you don't want to store it with the source code, but because it makes more sense to be in a data warehouse or lake to be consumed later, right? Because if it lived in the repo, it wouldn't be able to be consumed later, right?
Well, there's no reason why it couldn't live in version control, but the fact is, like I said, if it's binary data, it's not going to be handled very well by version control, and it could be massively big. It's just going to overwhelm the repository. And if the data is flowing quickly, that means there's going to be commits to version control very frequently, and soon you'll end up with more data than code in your repo. So let's say you're not going to put it in the same repo as your code. Put it in another repo, that's fine. But still, it's going to end up being a huge repo, like a huge change set. That data is changing continuously. And it all depends on the frequency of how much it's changing as well. But like typically when you're coding, building a product, you would only put the source material, the source code itself in version control. You wouldn't put anything that's generated. If the data is generated, that's not a candidate to go in version control with the source code for your product. It's suitable to go in a different code repository. I've actually done that, and it's probably a bit of an abuse of version control. but typically that that kind of thing is going to go in a database or like a data warehouse, as you said.
And my last question, or last set of questions, to connect actually what, because I'm very thankful not only that you took time to respond to my questions, but actually to respond questions about a topic that, I mean, although it probably interests you and it's part of your day-to-day life, let's say that you've moved past this years ago, probably. I mean, in terms of real interest and passion about, because right now, I mean, according to your latest publication, which is, correct me if I'm wrong, bootstrapping microservices with Docker, Kubernetes, and Terraform, right? Mm-hmm. Which is your ongoing publication right now. I would like to connect with that. I mean, how is repo management? How is that part of version control serving microservices? And then the deployment of those microservices in Docker, Kubernetes, is it right now a problem? Is it right now an enabler? Is it somewhere in between?
It's definitely an enabler. Like it's absolutely essential, really. I mean, you could,
because wait, let me interrupt you. How would you define a code base that, at a glance, you could tell, oh yeah, that's microservices? Could you give me a super high level definition of how a code base that is based on a service oriented, specifically a microservice architecture, looks like?
I'm not sure if you can tell. So if you were talking about, like, I work a lot with Node.js and JavaScript, and if you're talking about a Node.js microservice, it doesn't look that different to any other Node.js application. From the outside, it could be a command line application or something else. It could be like a monolithic web server, or it could be just a couple of lines of code that's a microservice. So looking at the actual project, it's kind of difficult to tell exactly what it's doing, just if you're just looking at the structure of the files in the project.
Okay. Then how do you tell that a project, that a software piece product is based on microservices, structured in a microservice? Am I getting too philosophical here? Probably.
Yeah, microservices need to be small and independent, and able to work in isolation. So,
but then going back to your previous comment, a monolithic server, would that be would that be able to fall into the small denotation that you just mentioned?
No. Well, by its name as a monolithic application, you basically
okay. I thought you meant
that it's not a microservice. But I actually think there's a spectrum with monolith on one side, microservices on the other, and where it starts and where it ends. Like people can argue about size for days. I don't know, but there's a spectrum of one big process down to many tiny processes. And typically, I would say that a microservice, if you can throw it away and rewrite it in a day or at most a couple of weeks, then that's small enough to be considered a microservice. But it's more about what it does than the size. Does it have a small area of functionality, well-defined area of functionality, and it could be thousands of lines of code to fill that one area of functionality.
Okay.
It could be 10 lines of code. Size is kind of relative. It's more about how small is the feature set. I would say.
And then going back to my initial question, because I actually interrupted you, how is version control enabling or actually discouraging from deploying this microservice?
Absolutely essential, because microservices, to scale up a microservices application, and you're building it as microservices because you want to scale it up, at least you want to scale it up at some time in the future.
Yeah.
To be able to scale it up, you need automation. So you need something that can manage and trigger that automation. And that's where version control comes in as the thing that you add the features to that triggers basically the deployment to production. All your automated tests will be part of that pipeline that basically control whether it goes to production or not.
Okay.
So, like absolutely huge microservice application, you cannot have it without automated deployment and without automated testing. And version control is right in the middle of that. It's a crucial factor of enabling that.
Okay. Because you mentioned Docker, in my mind comes up the actual image of a container, but you're probably referring to Docker Swarm. Am I guessing right? I mean, to the actual orchestration of those containers.
That's certainly a great product, but in the book I talk about Kubernetes as the orchestration platform. So we're using Docker to build our images, a container registry to host the images, and then we're deploying them to a Kubernetes cluster.
And Terraform, when does Terraform come in place here? Because Terraform is a provisioner. No, wait, what does Terraform does?
So I think of Terraform as a scripting language for creating cloud infrastructure. So in the book, we use it to create the container registry. We use it to create the Kubernetes cluster, and we use it to create microservices in the cluster. So it's an all-encompassing language, really, for deploying infrastructure on AWS, Azure, Google Cloud, DigitalOcean, and I think there's a bunch of other vendors that have providers, which is like a plug-in to Terraform that makes it kind of adapt to their system. So you can basically use it as a language to deploy anywhere on any of the vendors.
Oh wow! I'm not understanding the basic differences between, I don't know, Chef and Puppet and Terraform and Packer. Is it Packer? The other provisioning. I'm not sure, to be honest, what Packer does.
Packer is a tool from HashiCorp for building virtual machine images. For my purposes in the book, Docker kind of does that. So we use Docker to basically script the creation of our images. They're not virtual machine images; they're container images. It's a similar concept.
Yeah.
But what we need for Kubernetes is we need to deploy containers. So that's what we're using Docker for. What was the other thing you mentioned?
I mentioned on the one side Packer and Terraform, and then Chef and Puppet as infrastructure managers.
As far as I can tell with Chef and Puppet, and the reason that I kind of stayed away from them from the beginning was that they required an extra piece of infrastructure to work. I think they both require like a server to manage all the infrastructure recipes. Whereas Terraform doesn't need that. Terraform can, it can run on your local PC, it can run on your in your continuous delivery pipeline, and you don't need that extra server to kind of manage, all your files. Like that's kind of like what version control is for. So the thing that really got me into Terraform and not into Chef and Puppet was that layer of complexity basically got removed. And Terraform just seemed like a real simple entry point. And Terraform itself is kind of what made Kubernetes learnable for me, because when I was facing down Kubernetes about 2 years ago, trying to learn it for the new products that I was building, it just seemed like it was going to go in the too hard basket. Like, it seemed like I was going to need an operations team to manage that.
Yeah.
But Terraform actually, made it easy because I could hit all my cloud configuration, all my Kubernetes configuration, all my microservices configuration with one language. Since then, I've got much deeper into Kubernetes, but that's what comes with time.
Yeah, everyone says that Kubernetes is extremely complicated. Although one of the goals of it was to make it understandable, and it probably is in a way. But yeah, the paradigm shift between sort of like. I
was going to say, sorry. All of these technologies are actually pretty complicated. Docker, Terraform, Kubernetes, they're all really deep and complicated. Yeah. But the approach that I've taken in my book is that you only really need to skim the surface of these technologies to start using them and to start building products. And so in my book, we basically work through from the simplest possible beginnings of building a single microservice on your development PC. We work all the way through to having multiple microservices, database, a RabbitMQ server running in a Kubernetes cluster in the cloud. That comes step by step, but I also show along the way that you don't need to have that deep understanding of all the tools to do that. You only need to skim the surface. And then, you know, later on, as you're building out your product and fleshing it out as it becomes more advanced, you're going to dive deeper in certain areas. You know, what we call just-in-time learning, to kind of learn the deeper parts of it. And that's how we survive as developers on small teams building really complicated products these days.